Hello everybody. Today we're going to talk about simplifying expressions. On your resource page, I think it's under, under the classroom resource page, there are some posters. So if you will scroll down and find Unit 1 posters, you will see a picture of this stuff up here. And then what you can do is take your phone and take a picture of it, and that way you've got that poster sitting on your phone that you can see up close to you if you can't see them here on the video. Okay, today we're going to talk about simplify. Simplify is on this poster in simplifying expressions. So first of all, we need to talk about expressions. Expressions are a part of an equation. Well, what's an equation? Equations have equal sign. Equation, equal, they both start with that. So equations have an equal sign and they have something on both sides of the equal sign. It's a complete mathematical sentence. If they ask you to solve an equation, they have to give you a complete equation. Otherwise, you cannot solve if they do not give you an equation. Okay? Now, the other thing they're going to do is say simplify an expression. An expression is part of this equation. So if I get rid of this, 3 plus 5 is an expression. If I get rid of the first half, 8 is an expression. It's just part of an equation. So expressions are just parts of the equations. If it's an expression, is there anything to solve? No. Okay? Sometimes they have variables, sometimes they don't, but there's nothing to solve if they do not give you an equation. Instead, what they'll probably do is say simplify. Take something that's big and make it simplified. So you would say 3 plus 5 simplifies down to 8. All right? So you're just taking something big and simplifying it down when it's an expression. So let's look at some fancy versions of this. Generally, when you simplify, you're going to do two things. You're going to combine any like terms, and if you have any parentheses, you're going to use the distributive property to get rid of the parentheses. So in this first problem up here, do you see any parentheses? No, so I don't need to worry about the distributive property. However, I do see some like terms, L-I-K-E, like terms. So 6x and 2x are like terms because they both have an x in their terms. The 4y is not a like term with the 3, but it is a like term with the negative 4y. Okay? So if they both have y's in them, they are like terms. Now this negative 3 doesn't have any variables in it, so it is not the same as the y's, and it's not the same as the x's. It can only go together with other plain numbers. So when we combine like terms, the x's can combine together to make a new term, the y's combine together to make a new term, and the negative 3 would combine with any other plain numbers, which there aren't any in this particular one. So here we have the x's. Let's do the x's first. I have a positive 6 and a negative 2. So these are your integer rules again. 6 somethings minus 2 somethings. Obviously the good guys are going to win. 2 of these kill 2 of those, so how many are left alive? I have a positive 4 somethings. 6 somethings minus 2 somethings is 4 somethings. Don't change the somethings, they stay with that x. You don't have to put the plus sign in front of it unless you just want to. My y's can go together. I have 4 bad and 4 bad. So 4 bad guys and 4 bad guys. Altogether, how many bad guys do I have? You're right, I have 8 bad guys. So this is minus 8, and those are y's. So negative 4 somethings minus 4 somethings is negative 8 somethings. Again, don't change the somethings, they stayed as y's. So the x's have been combined together, the y's have been combined together. The only thing that's left is this negative 3, so I'm just going to write negative 3 down there at the bottom. Had there been another, just a plain number, I would have combined the plain numbers together. Now, it doesn't matter whether you put the negative 3 at the beginning or what order, as long as this term is positive, this term is negative, and that term is negative. Most mathematicians will put that constant, the plain number, on the very end of that sequence of terms. But mathematically, it doesn't matter which order you put them in. Okay? This is your final answer. It is only 3 terms as opposed to 1, 2, 3, 4, 5. I had 5 terms in the original one, and I'm down to 3 terms in the answer. You have to know when to stop. X's and y's are not like terms. They cannot be combined together. The negative 3 does not have an x or a y, so it can't go with any of the other ones. So that is your final answer. You got to know when to stop. Now, number 2. Again, we're simplifying. There is no equal sign in this. It is not an equation. I cannot solve it. They could not ask me to solve it. Can't be done. But what they can do is ask me to simplify. So we're going to take this big thing and try to condense it down into a smaller answer. I see parentheses, and I'm thinking PEMDAS, I should do, parentheses first. So you look and say, oh, inside x minus 4. Can you combine an x and a negative 4? Are they like terms? I'm thinking not. The 4 does not have an x after it, does it? So they are not like terms. Can you do what's inside the parentheses? No, you cannot. So when you cannot do what's inside the parentheses, to simplify, what you can do is use the distributive property to get rid of the parentheses. And what you do is normally you would do the math inside the parentheses and then multiply it times that negative 2 sitting in front of it. Since I can't do what's inside the parentheses, I can do the multiplication first. I can multiply negative 2 times the first term and negative 2 times the second term. That's the distributive, because you're distributing the multiplication to everything inside the parentheses. So negative 2 times 3 is a negative 6 with the x after it. Negative 2 times negative 2 is a positive 4. And the parentheses are then gone. So that's what we're going to be using to simplify. So when you see simplification and there are parentheses and you cannot do what's inside, how do you get rid of the parentheses? You're right, the distributive property. Negative 3 times the first term. There's a 1 sitting there if you want to put it there. Negative 3 times 1 is a negative 3. And there's an x being multiplied with it, so I just leave the x with it. Negative 3 times negative 4. Negative times negative gives you a positive answer, and of course 3 times 4 is 12. So far I have distributed this to both pieces inside the parentheses. I do not keep distributing it because these things are not inside the parentheses. Only distribute to inside the parentheses. So this part is done. Parentheses are now gone. Poof! Which is what I wanted. That's why you use the distributive property. Finish writing the rest of this down. Minus 5x plus 3. Now that parentheses are gone from that expression, can I combine like terms? Absolutely. I see an x here and an x there. I see a plain number there and a plain number there. So the x's can go together and the plain constant numbers can go together. So bad guys and bad guys. How many bad guys do I have? You're right, I got 8 bad guys, so this is minus 8x. Negative 3 somethings minus 5 somethings is negative 8 somethings. Don't change the somethings. Then I have a positive 12 and a positive 3. A lot of good guys. How many good guys do we have altogether? You are correct, positive 15. Now, the question is, can I combine this negative 8x and the positive 15? Can we? What do you think? I heard you. I think you're right. We cannot combine them. Why can we not combine them? Because they are not like terms. Had there been an x with the 15, then I could have combined them. But there is no x with the 15. They are not like terms. So this is my final simplified answer. This whole big thing up here simplified down to negative 8x plus 15. Okay, so you got to know when to stop. You have a little assignment that you're going to do where you're going to be practicing distributive property and combining like terms. Bye.